Hi everyone, welcome back to my math teaching online today again. Um, today, just let me mention one thing to you because I knew that we went through a very difficult year. However, Christmas is coming. I hope that everyone will forget about the difficulty, the isolation we experience, but let look at the beautiful nature. Like in my area, there's the mountains and the snow on top of mountain. It looks so pretty. So the beauty of nature stay its own beauty. So I want to say Merry Christmas and Happy New Year to all of you. And that will give us the hope for looking forward into the future. So let me get right into the lesson today. And in the lesson today, I am talking about the iteration again. In this unit, we are always talking about iteration. However, there are so many types of iteration. We have iteration by substitution by U. We did some trigonometric iteration before. However, the lesson today is a little bit special because why? There are some formulas not appear in our derivative formula, right? So we have derivative, antiderivative of sine x, which is equal minus cos x formula, antiderivative of cos x equal sine x. We have an antiderivative of cosecant square x equal to minus cot x. But there are some not appear, and because of that, we have to use the trigonometric identity related to the iteration. And therefore, I told you math is the progressive sequence of steps. And if we're missing one of the steps, we are in trouble, right? So in the past, in Math 12, you have learned trigonometric identity. Now we're going to use them into our iteration lesson today. However, I'm going to sell out my tip to you. Now, why do I say I'm selling out my tip to you? Because I remember when I was in university back in the time when I was learning, I was so struggling because we didn't have a YouTube. And sometimes the professor just taught us the textbook without the lesson on the board is nothing to do with the practice exercise they gave to us. Most of the time it looked like that. Back in my day when I was learning in the university 20 years ago, right? 20 years ago, 15 years ago. Right now, we do better. We have a YouTube, give out the free education. So it's very privileged to you. Life is balanced. So even though we have a pandemic going on, but you have something compensate for that. You have free education on YouTube. You have online lesson plan on the rate course creator, and one of them like me. I'm just kidding. To give out the lesson, right? Free lesson, and therefore you have a privilege. So even though your education was disrupted by one way or the other by the situation of the family, but we try our best to cope with the reality and give out the best thing to compensate whatever we have to went through. I just found life is balanced, right? Anyway, it's hard. It's not easy. Life is difficult as well. So that's why I want to make it easier for you guys to learn. I selling out you the tip. Now, maybe you like my tips, or maybe you refer the other tips from other professor, other teachers, then that's great. You can, if you like my tips, you can use my tips. If you prefer the other tools you learn, then use the other tools. The only good thing in math, if we do it right, we get one answer correctly, or at least it's similar according to the formula, right? So that's the part. Anyway, let me get into the tip now. I'm telling you that I'm selling out my tip. So give me some money and then get my tips, right? I'm kidding. So this is the tip. Rules to remember. Rules to remember. Remember, we don't have the formula. So that's why we have to use this tip. So what is my first tip? Let's say if you integrate some expression, sine to the power mx times with cos to the power nx dx. So my first tip is say if m or n is odd, odd power, right? So if, then use this. So if, then, right, use substitution, and I put in the short form. Substitution 1 minus sine square theta equal cos square theta. So we use this first trigonometric identity. Everybody know about that. Sine square x plus cos square x equal 1. So we transfer the equation, what we got, okay? Okay, so that's how it look like. Now, if this, then this. So sometime, and if this is the case, you will make u equal sine theta. Sometimes you might substitute 1 minus cos square theta equals sine square theta. And if this is the case, then you might use substitution equal cos theta. Now, you might say that, I don't know what she's talking about, right? However, I will show you the example which is related to these tips, and that will make you feel more comfortable, okay? So just bear with me for now. Let's reading my boarding tips and until you see how it applies into it, okay? So now, the second tip I give you, if the m power here and the n power here, if n and n, and they're not r, right? Even power, right? So if this, then use this. Use double identity. Okay, double angle identity. Double angle identity. And if you learn Math 12, you know what I mean, right? The double identity, so for example, sine square theta will be equal 1/2 1 minus cos 2 theta. And because we have a double angle, so this become a double trigonometric identity. And cos square theta will be equal 1/2 times with 1 plus cos 2 theta. Now, this it comes from the trigonometric identity. Let me, maybe I should show you, recall a little bit your memory, right? So if you learn the double identity. So you know that if you have a cos 2 theta will be equal, the first formula will be cos square theta minus sine square theta. The second formula will be cos 2 theta equal 1 minus 2 sine square theta. So then if you transfer cos 2 theta will be equal cos 2 theta, and if you bring this over will be minus 1 equal 2 sine square theta, actually equal minus, right? And then if this, you divide it by 2, and actually you divide by minus 2, then you get this. And this is the same like you write like that, right? That's exactly the same. Okay, if you time minus 1 with the top and the bottom, you get 1. This become positive, right? If you time minus 1 top and bottom, so you get that. Okay, so that is how it comes from. The same like if you I transfer the third formula is cos 2 theta will be equal 1, instead of adding will be like this, 2 cos square theta adding 1. So that will give you these two identity. Okay, so that is just a remind to you about this. I don't have to leave it. Okay, so just follow the tip here. Okay, so just follow these two tips for now. Okay, now I'm going to give you a third tip as well. The third tip is if the function involving this kind of form a square minus x square, then use what? Use substitution sine theta equal substitution x equal a sine theta. So that is the third tip I give you. Okay, so just follow this third tip and I will show you which one we doing it. So that's the first one. The tip is if m or power n here is on, then you use this. The second tip, if m and n are even, then you use this. The third tip is if the function involving the form like that, then use this substitution. Okay, so this is my tip selling out to you. Okay, now you will enjoy it after I give you the example. Let's take a look at the first example. I'm not going to remember the question, so I have to copy the question first. Okay, so in my lesson plan, the number one I'm going to be selling out to you today is, including with this tip, is this. Let's apply the first tip. Cos to the power 3, you see it odd, right? X times with sine to power 4 x dx. Now in this tip we say if m or n. So you see this m is odd and m doesn't matter. M can be odd or can be even, doesn't matter. So let's do this question now. And let's apply which one? Do we apply number 1? Yes, right? Then use substitution 1 minus sine square theta equal cos square theta. I'm going to use x in this case, right? So before I do that, I'm going to split this, become cos square x times with sine to the power 4x times with cos. If I take this 2 from here, then I have 1 left, right? Power 1 dx. Okay, now the reason because I want this to be together. So now I'm going to use this expression, right? We change the cos square x, which is cos theta, become that. So now let's see what happened. I'm going to change this become 1 minus sine squared x times with sine to power 4 x times with cosine dx. Now this will become I'm going to multiply it through, okay? So I will have sine of 4x times with minus sine of 6 power 6, right? I add power x cos x dx. Now I'm going to say make u equal sine theta. So I say let u equal sine x, right? X theta here is sine x. So du over dx, right? Derivative of that will be derivative sine is cos. We have formula for that, right? Cos x du equal cos x dx. So now I can substitute this by u. So I'm going to substitute this by u to the power 4 minus u to the power 6 and cos x dx. I'm going to substitute cos x dx by du. Now because it's easier for me to evaluate the u instead of the x, so I don't bother to substitute back, okay? I'm just integrate this to make it easy. So I will have, now I'm going to leave this numerical value for now because this is not applied for u, it applies for x, right? Just leave it for now. We'll integrate it out first. And that will be equal 1 over 5 u to the power 5. Everybody know how to do antiderivative now. 1 over 7 times u to the power 7. Now I'm going to have to substitute this value by numerical value of u. So let's do that. So what do I say? I say let u equal sine x. So u will be equal sine, and the x I substitute by pi over 2. And sine over 2 is 1. So u equal 1. So now we substitute this by 1, sorry. So 1. Now sine of 0 is just 0. So that's same thing. So now I'm going to evaluate this. So I will have 1 over 5. U is 1 to power 5 minus 1 over 7. U is 1 to power 7. And this is same like 1 over 5 minus 1 over 7, and that equal multiply common denominator, we get 2 over 35. And that is the answer for this iteration. Remember, in the past, when I show you how to do substitution u, I then went through with you how you change the value numerical here from x to u like this. But today you learn one more step. The reason because the lesson we learned in the past is it's not necessary to change the numerical value because it's simple enough for us to substitute back to x. So I just do the same. Now I found that math is already lengthy and complicated. So anytime we can do the shortcut and cut out the redundant task, then I try to do that, right? That's my philosophy of teaching math, okay? Unless sometimes we have to learn on the long way, follow on the formula, follow on the tip like this, substitute in and make it, then we have no choice. And at that time, not up to my knowledge that on I know, so then I will do that. But anytime if I can skip step, I can make it shorter, I can cut the redundant tasks, then I do. Because to me, math is already complicated. I don't want to make more. The longer we make, the more mistake we make, right? In numerical value, by substitution or whatever. So that is my philosophy of teaching math. If I can deal with it, I can figure out how we cut short, then I try to do that in my lesson plan. And unless I have to do it in the long way, then I will have to follow the rules, do the long way, right? Okay, so this is how I cut short, right? In last time lesson, I didn't show you how to substitute the numerical value here from x to u. But today in this lesson, I found necessary because it's so much easier when we change from x to u rather than substitute back and so on by x angle again. So this is how I show you. Now, I'm going to go to the next question. So this is number 1. I'm going to do number 2, right? And I have to erase this so that I have room to show you, because I want to keep the tip here for to prove to you that yes, we do follow the rules, right? To be honest with you, when I learned this topic before in university, no professor taught in the rules for me. They just give me the textbook, that's it. And sometimes it's not even mentioned in the textbook, right? Okay. So now, let me show you the second question. Okay, let's do this question now. We're going to evaluate from 0 to 5. And 25 minus x squared dx. Okay, in this question, what do you notice? What tip we're going to apply in here? Number 1 is not, right? Number 2 is not. What about number 3? Yes, we have the expression look like that. A squared minus x squared. So then we're going to use tip 3 to do this question. Now let's check the formula here. Did you see anything look like that? This one look a little bit like that. However, or this one. However, we don't have the one on top. So this is the inverse trigonometric function. So you can apply this formula for this expression, but not for this, even though they look a little bit similar, right? Okay, so let's do the integration now. Follow the third tip here. So we substitute x equal a sine theta. So this is our a, and our a is actually 5, right? So we say let x equal 5 sine theta. So now I'm going to substitute, and I'm going to leave this numerical value here, okay? We just substitute for x. So I will have 25 minus 5, x squared is 5 squared, which is 25, sine theta squared, right? Or sine squared theta, the same, okay? And now, how do we substitute the x? If we say let x equal 5 sine theta, it means dx will be equal derivative of 5 sine theta will be 5 cos theta, right? 5 cos theta. So we're going to substitute the dx equal 5 cos theta in here. Dx equal 5 cos theta. And actually cos theta d theta, right? Dx over d theta. And I bring it up here, okay? So we have d theta as well. So now, what do I do next? I'm going to factor out the 25 here. And I'm going to have 1 in here, right, for that number, minus with sine squared theta. And I have a 5 here, cos theta, d theta. I'm going to just put cos theta and d theta for now, because the phi is the multiplication constant, we'll bring it out here. Okay? But don't forget that if you take it, everything inside square brackets. So this number 5 apply for the whole thing in here. Okay? So 5. Actually, the 5 here multiply with, yeah, okay. So that's the case, right? Now, again, I'm going to take this out as well because that will allow us to take square root 25, and 5 times 5 is just 25. So all of this 25 will be outside here, and inside we left with this 1 minus sine square theta. But I'm going to substitute 1 minus sine square theta is cos square theta. Okay? Because that's a trig identity, right? And this will become cos theta down here as well, out here as well. However, it turned out I can take the, and make sure this still in the integration, right? I still take cos square theta outside. So that will become cos theta times cos theta will be cos square theta. Because I take the square root of cos square theta become cos theta, time with that become cos square theta, d theta. Unfortunately, we still don't have a formula to integrate this. So at this point, what should I do? Cos square theta, d theta. I'm going to use this because look, what tip I supposed to use here. This now become a even power. So when either m or both of them are even, I'm going to use this. So cos square theta, I'm going to turn out it become double angle identity. And double identities become 1/2 times with 1, adding with cos 2 theta and d theta. Now at this point, I should change the value from 0 to 5. So let's change that. We know that x equals 5 sine theta, right, from here. That's how we do at the beginning. So x divided by 5 equal, if x equals 5, I substitute, it means 5 divided by 5, which is equal 1. And 1 equals sine theta. So if sine theta equals 1, theta will be equal pi over 2. Yes? And if sine theta is 0, then it's 0. So now I know I can change this become pi over 0 go to pi over 2, right? And this is just 1/2 time with 1, adding with cos 2 theta, d theta. Okay, at this point, I'm going to integrate this because now I do have a formula. So I have 25, go from here to here, right? 25 times with 1/2, I just bring it outside, right? And inside, I left with 1. Now, it turned out if I integrate, it will become an angle theta, right? 1 become 1 theta, antiderivative of that. Adding with cos 2 theta, now the antiderivative of cos is minus sine. So that, instead of adding, will be minus sine. No, is that right? The antiderivative of sine equal minus cos. The cos equal positive sine, sorry. So that will be sine 2 theta. And what else? Don't forget this 25, okay, let me rewrite it. This 25 outside bracket, and this 1/2 multiply here, apply for both of them, right? So I'm going to say this is 25 over 2, right? sine positive, right? And it should be positive, not negative, 2 theta. And we're going to evaluate from 0 to pi over 2. Okay? So now this will give us 25 over 2 times with our angle theta is pi over 2. Adding with 25 over 2 times with sine of 2 times pi over 2. And minus everything multiplied will become 0. So we're not worried about that. Now 2 here will cancel with 2 here. So we left this with 25 pi over 4. Adding with sine of pi equal what? Sine pi equal minus 1 and 0. So sine pi equals 0. Right? This numerical value. So this whole group will be equal to 0 because 0 times with anything is 0. So now we're left with this answer. So that is the answer for our iteration, like that. Okay? So you see that this powerful tip, right? It makes our life is a lot easier when we do the iteration. We just follow it, follow my tip and run for it, right? Run for the election. I'm just kidding. So let me give you one more question of how my powerful tip look like. And don't worry, I know this level is a lot and a lot of writing, a lot of copy down. So I already put in my course for you all of the notes available and accessible to you, all of my tip. If you register into my math courses -online.teachable.com. That's my website with all the course, right? Okay, so now I'm going to give you the next question. And the next question, let's say what the next question is like. Okay, let's do a little bit more interesting question. The question 4 or 3, I don't know, maybe 3. Okay, 3. Question 3 here is integrate. Now I'm not going to put in the value. Make life a little bit similar. Sine square x, cos square x, dx. Okay, I'm going to do this. Now, keep in mind that you don't have an antiderivative of sine square x and cos square x, and that's why we have to use on this powerful tip from my experience, okay? Okay, so now let's do the number 3 tip. Now, number 3 question. What tip will we use? Do we use this one, or this one? It doesn't look like we have m is square, n is almost square. So we're going to use a tip secant, which is both m and n are even. So they are even power. So we're going to apply this double angle identity, right? So what's it look like? We're going to apply exactly like that. So for sine, we have 1/2 times with 1 minus cos 2x. For cos, we're going to have time with 1 over 2 again, exactly like that, right? The same. Time with 1, adding cos 2x. Now, because 1/2 and 1/2 multiply together, I can make it become 1/4, and I'm going to just make it like that. Just leave it for now, okay? 1/4. And I'm going to combine these two brackets together. Now, 1 is negative, 1 is positive. However, they're exactly the same expression. So this is same like a minus b times a plus b. And a minus b times a plus b equals a square minus b square. That is a perfect formula, right? So I'm going to combine this and become a square is 1 square, which is 1, minus b square is cos square. The angle is 2x, right? So dx. Okay, so at this point, what do we do? Now I am okay, let's see. I'm going to just keep the same, right? Now 1/4 times with 1/4, right? No, I'm not going to multiply it yet. Just leave it for now. So I'm going to put in the bracket. This is still 1. However, when I look at this, we have an even power again. We don't have formula to integrate this. So what do? This equals square 2x. So I'm going to apply this one more time, right? If m and n are even, we're going to use this. And this is the expression we should use. So one more time, this will become 1/2 again. Inside will become 1, adding with cos double angle. Now, our single angle is already 2x. So double angle will be 4x, right? 2 times 2 is 4. So our angle now change from 2x to 4x when we do identity again one more time. And all of that in the bracket with big bracket outside. So remember this 1/4, when you multiply here, become 1/4. But this will change into 1/8, right? Okay, but let's simplify this one first, because this is, no, we cannot do that. The reason because this is attached to this one. So if you want to simplify, you have to tie in the mean first. So let's leave it for now, okay? Let's see what I can do. Okay, so if I want to change this, just multiply it through and see what happens. I'm going to multiply it through here. So we have 1/4 times 1 is just 1/4, right? But this will time this as well, so that will become minus 1/8. And inside we have 1 adding with cos of 4x, right? Yeah, okay. What else can we do? So this time with that become that. Okay, so now we're going to say that this is dx and this is dx. So now we're going to integrate this. At this level, we can integrate it. So take it outside, 1/4 become 1/4x, right? And this we have to multiply back before we take it outside. This time with that is just the same like 1/8. 1/8 minus, and minus just minus when we take it outside, so that will become 1/8x when we take it outside. And this will attack to this when we bring out as well, and that will be minus as well. Now, the antiderivative of cos is positive sine x, so that should be negative. That's right. So that will be minus 1/8 sine of 4x. And we don't have evaluation, so that's good. Okay, so now let's do it. Simplify it. We're going to simplify this two number. And 1/4, so I'm going to time this with 2 and top time with 2. So I have minus 2. So minus x/8, all of them in the same common denominator, and minus 1/8. One more thing I forget. What do I forget? I'm so sorry. When I take this out, actually, I change this, but however, remember I have to have a times with 1/4. So that will be like that, actually, okay? So this number will become minus 1 32 over 32 sine 4x. Okay, unless you figure out any of my mistake, I don't think so. I multiply through this so that become that. I multiply this to that so that become that. I multiply this to this so this become this. I multiply this with this so this become this. Yes, it's the only number I forget. Okay, so that become minus 1 over 32 sine 4x. So again, we're done with this question. And this is negative, that's right, because, oh, wait a minute. This is 2 positive times minus 1. So, sorry, this should be positive. Okay, so that should be x over 8 minus, when I do common denominator, this is 2 minus 1, so that should be positive. And this is the antiderivative of cos x is sine x. The antiderivative of sine x is minus cos x. Yeah, so that's how it looks like. Okay, so we're done. Now I'm going to give you maybe one more question. Let me see. Do we have any more interesting question? I should give you. Yes, one more interesting question. Now I choose on the more challenging question to pick you, right? I don't choose the easy question, to be honest. So the easy one, I leave it for you as an exercise practice. Okay. So my last question to you is number 4. Not in the tip I gave it to you. This is a little bit special, so I just want to selling it out to you for free. Okay, so let's check. The number 4 question will be integration of tan theta. No, sorry. What I'm trying to do? X to the power 3 over square root of x squared minus 1 dx. So in this case, you want to connect it back to the, let me connect it back to the, now if you look at this formula, right, you can see that something, see both negative, but this is adding, and actually this should be adding, sorry, dx, yeah. So let me check the question one more time, make sure that I write it down correctly. Good, so in this case, you will use, this is Spencer K, right? Spencer, use tan theta, okay? Tan square theta. And we have the, because we related to something like that. Now we have the identity, trig identity, secant square theta equal tan square theta plus 1. So now I'm going to substitute this x. So I'm going to say let x equal tan theta. So now I will substitute this by 10 to the power 3 theta on of this over square root of x squared plus 1. So I say substitute this by 10 square theta plus 1. Now this will be dx, but if we say let x equal 10 theta, so then what dx? Dx over d theta will be equal, derivative of tan theta is secant square theta and d theta. So now I'm going to substitute this dx here by secant square theta d theta, because this is how it looks like, right? So I substitute the dx by this expression. So now what do I have? Now I'm going to, let me see what else I forget. Actually, sometimes I do forget, right? Okay, so I'm going to change this into this. That's what our purpose. So on top, I'm going to say the 10 square theta. I just split it like that. I'm going to join with this one. The 10 theta secant theta d theta. So I split one of them and I join here. Down here, I'm substitute this by secant square theta. Okay, now fortunately for me, I can take square root of secant square theta. So on the top, I still have 10 square theta on of this over secant theta. And here I have 10 theta secant, actually this should be square, I'm missing that, right? D theta. So now this evaluation turn out, I can cancel the number 2 power here with the number 1 power down here. So that's gone, and it gave me 10 square theta on top over, actually it gone, no over, nothing over. So just 10 square theta, right? And 10 theta secant theta d theta. Okay. So at this point, I will say let u equal let me see. How do I change this? Okay, so we have secant square theta minus 1 equal 10 square theta. So I'm going to substitute this back as secant square theta minus 1. I substitute for that, right? From this trigonometric identity, I just move this number 1 over. I subtract that. It will be equal 10 square theta. So all of this going to be in the bracket. And out here, I still have this. Now, if I say, let u equal secant theta, what will happen? Let u equal secant theta, then du over d theta will be equal secant theta, 10 theta, d theta. And that's what I want it to look like, right? So now I will substitute this by u, because I said let u equal that. So u secant theta. So that u square minus 1. And du we substitute for the whole thing here. So du. So now I can integrate them easily, right? So now I will get what? The answer will be 1 over 3 u to the power 3 minus 1 here become u. Okay. Now, if I have to evaluate this, then I'm going to substitute back if I have the numerical value. But I don't have a numerical value, so I just say let's see for now. And now, because we have to substitute back when we don't have a numerical value, right? So I'm going to substitute back, okay? So, how do I substitute back? Oh, I just erase everything. What do I say at the beginning? I say let 10 square theta plus 1 equals secant square theta. And I say let u equals secant theta. So after I integrate that, will be 1/3 u is secant theta, and that is secant theta, minus u, we minus secant theta, and let's see. So that's how we integrate the trig here with the special thing, right? Yeah, so that we done, and this video is kind of long. So I hope that you enjoy my tip here and you enjoy this lesson.